Solving this equation for z is the same as finding the square roots of 15 plus 8i. For any number apart from 0, there will be 2 square roots, so we're expecting 2 solutions here. The key is to let z be equal to a plus ib, and then form 2 simultaneous equations in a and b by equating real and imaginary parts. Solving those for a and b will mean that we've found z. So z equals a plus ib. Now we expand the left-hand side, and now equate the real parts and the imaginary parts. This gives us 2 simultaneous equations in a and b, which we can label and solve by substituting from the second into the first. From equation 2, b equals 4 over a, and substituting that into 1, we get this equation, which needs to be simplified. So we've got a quadratic in a squared. Let's hope we can factorise it. A squared equals 16, or a squared equals minus 1. But remember that a has to be real. So a can be plus or minus 4, but there are no solutions from the second part. Now that we've got our values of a, we can substitute back in to find the corresponding values of b. Here they are. And here are our 2 solutions, which can be written in a more compact form like this: z equals plus or minus 4 plus I. And when you think about it, because it's square roots, you'd expect it to be plus or minus something. So now we've got to check, and we'll want to make sure we get our logic right, so we're going to start with the left-hand side. Substitute in our first solution, and see what we get by expanding. It's the same as the right-hand side. By the way, that's not supposed to be a picture of me. It might look like me, but it's just a general happy person. It could be you. Here's a summary of the method. Substitute in a plus ib for z, expand the brackets, and equate real and imaginary parts to make simultaneous equations in a and b. These equations can be solved, and when you write down the solutions for z, you should see that they're plus or minus something, because you're taking square roots. That's what you'd expect. Normally, if there are 2 solutions, you'd have to check both of them, but I hope you understand why for this particular type of question you only have to check 1. And make sure you get the logic right. If you end up proving that a number equals itself, something's gone wrong.